What if every microwave oven in America ran at the same time for 1 minute? Would the grid melt, lights dim, or nothing at all? Let's run a Fermi estimate. Assume about 120 million microwaves. Take 1 kilowatt of electrical power per oven. Duration, 60 seconds. Instantaneous power equals number times power. That is roughly 120 gigawatts. Energy equals power times time. 60 seconds makes about 2 gigawatt hours, or 7.2 terajoules. How big is that? Compared to the US grid, which normally supplies hundreds of gigawatts, the energy is tiny. But the sudden step in power, 120 gigawatts, is not tiny. Real microwaves also have a short inrush. For a fraction of a second, the spike can be around 2 times the rating, so the peak could touch 200 to 250 gigawatts for an instant. What would the grid do? System frequency would dip as generators slow down, automatic controls ramp turbines and batteries, some regions would import power, others shed non-critical load. You might see brief dimming or localized brownouts, especially on weak feeders. But nationwide collapse is unlikely. The average energy, 2 gigawatt hours, is what the grid delivers in a minute or two on a normal day. What about the heat? 2 gigawatt hours is enough to boil several Olympic pools by a few degrees, but that heat stays inside food and kitchen air, not in the power plants. And the radiation? Microwave ovens are shielded. If the door is intact, the extra risk from all of them running at once is not a thing. Bottom line, huge momentary power bump, tiny total energy. Grid dips and recovers, no doomsday. Comment math if you want the spreadsheet and assumptions. Subscribe for more absurd questions, Rio Math.